So continuing off the previous video, let's take a look at number 3, where we have x squared plus y squared plus z squared minus 6x plus 4y minus 2z equals 11. And let's say we're given the equation of a sphere, and we have to find its center and radius. So it doesn't really look like the equation of a sphere at first, but what we can do is rearrange the terms and complete the square. So the first thing I'm going to do is obviously combine like terms here, or at least group like terms together. So we have x squared here, and then minus 6x, and then I'll combine the y's together, so we got plus y squared plus 4y, and then we got the z's, so plus z squared and then minus 2z, and that will equal 11. So let's just focus on x squared plus 6x or minus 6x first. So if I bring this down here, x squared minus 6x. Now in order to complete the square, we must have an a term, we must have a b term. So a is just 1, b will be the negative 6, and then we have the plus c, which is the c term. And so in order to complete the square, all we have to do is take the b term, so negative 6, divided by 2, so then we get negative 3, and then squared. And that will be our c term, so 9 is c. So if I were to rewrite it, we get x squared minus 6x plus 9. And remember, if we add 9 to the left side of the equation, we must add 9 to the right side of the equation as well. And so notice this is a perfect square, x squared minus 6x plus 9, because we can turn that into x minus 3 squared. Because if we FOIL x minus 3 squared, we will get back to x squared minus 6x plus 9. So I'm going to go ahead and replace x squared minus 6x with x minus 3 squared. And notice we added 9 on the other side because we added 9 on the left side as well. So I'll rewrite it as x minus 3 squared. And so now let's focus on the y variable. So the y variable here obviously is, or the two y variables are y squared plus 4y. So we get y squared plus 4y. Now, once again, to complete the square, we must take the b term, so 4, divided by 2, so we get 2 and squared. So we get y squared plus 4y plus 4. If we add 4 on the left side, we must add 4 on the other side of the equation as well. And so this, once again, is a perfect square. And we can be rewritten as y plus 2 squared. So this is going to be, I'll replace that with y plus 2 squared. So we get plus y plus 2 squared. And then let's focus on the z variables. So now we have z squared minus 2z. So once again, we're going to take the b term, divided by 2, so negative 1, and then negative 1 squared is a positive 1. If we add 1 to the left side, we must add 1 to the right side, and this can be shortened into z minus 1 squared, because it's a perfect square. So I'll rewrite z squared minus 2z as z minus 1 squared. And then on the right side of the equation, we have 11 plus 9 plus 4 plus 1. So we get 11 plus 9 is 20, plus 4, 24, and then 25. So now this is the equation of a sphere. This is what we were familiar with as the equation of a sphere. So now we can find its center, obviously, and its radius. So its center is going to be at, notice it's 3, so a positive 3. We have, since there's a positive 2 here, it's actually going to be negative 2, because remember the formula is always, the formula is x minus, or x minus the coordinate, so let's say x minus h squared plus y minus k squared plus z minus l squared, and that will equal r squared. So if there's a minus sign, that tells us that the coordinate is positive, and if there's a positive sign, that tells us that the coordinate is negative. So we have 3, negative 2, and then our z is negative 1. So it's just going to be 1. So that is going to be our center value. And the radius, remember, it's going to be r squared. So if the radius squared is 25, 25 is equal to r squared, that means our radius is the square root, or in other words, our radius is going to be equal to 5. So that is the center and the radius of this sphere.